XMP stands for Extreme Memory Profile, and this was developed by Intel back in 2007 for DDR3 memory kits. It essentially is a preset programmed group of settings that's programmed within the memory module.
The idea there is we store the frequency, latency, and voltage settings required for various overclocked levels. We store that in the SPD chip on the memory module. That's serial presence detect. It's a little memory that's stored on the memory module itself. And it's essentially, think of it as like an Excel table. So when we have XMP profile 1, you could think of that as one column, XMP profile 2 is another column. So we have a variety of frequency, latency, and voltage pairs that are stored there. And then those can be easily recalled by the user through BIOS or other means to make your overclocking become a simple one-click solution.
It allows you to easily and quickly, gain an extra few percent of FPS in games, or for content creation or memory intensive applications. The more performance, the better and quicker you can get your job done.
Traditionally, before XMP was available, you install the memory kit and then you have to dig into BIOS, manually change the settings for memory frequency, memory latency, and the voltage. With XMP-enabled memory kits, it makes memory overclocking a lot easier in two ways. First of all, instead of going around and digging in through manual settings in BIOS, all you have to do is enable XMP, make sure you have the latest BIOS version, and then save it. It'll boot up automatically. So there's none of the guesswork and trial and error that you have to do with manual memory overclocking. In terms of the second point is that memory module manufacturers now can guarantee and make memory modules with that XMP profile. And as long as you install that on a compatible motherboard and with a compatible CPU, then just enable XMP and then it'll reach that rated memory speed.
So the history of XMP, it started in 2007 with DDR3, Intel being the primary driver of the specification, but they also worked with all of the motherboard manufacturers and memory module manufacturers to implement and refine the spec and allow end users to have an easy one-click solution for overclocking the memory.
It wasn't until DDR3 that we implemented XMP, what we called 1.1. We went straight to 1.1, and that was for DDR3. And then XMP 2.0 was for DDR4. And then more recently, in the last couple of years, we had XMP 3.0 for DDR5. So that's kind of the progression. And each time we've added additional features, capabilities to really improve that experience.
So 3.0 and DDR5, I would say, versus the DDR4 and 3.2, the highest changes is we involve in more profile. Like we have 5 profile and 2 included with rewritable profile. The second one will be like in profile, we can define the profile name. So it is easier for us to share. This is the, for example, for the DIMM vendors, they use this specific frequencies and the parameter on the specific board or specific platform. On DDR5 XMP 3.0, we also develop and deliver the spec and the requirement for the PMIC vendor to follow. So not only Intel not only define the requirement, we also validate the requirements. They have the same qualities and everything is on spec and good quality parts for the industry.
With XMP 3.0 on DDR5, we're actually seeing a huge performance jump in memory bandwidth. So for example, with DDR5 8000 on the 13th generation Intel Core platform, we're seeing bandwidth of up to 100 gigabytes per second. And this is on dual channel as well. So the last time we're actually seeing this was on a quad channel platform with the Intel X299 platform. So we're actually doing the same work, the same bandwidth performance as something that required higher number of channels, memory channels from before. So with less channels, you have less throughput, but with higher memory frequency, you would counterbalance that and reach the same bandwidth performance. If you increase that memory frequency further with dual channel, then you can possibly, with the right architecture, with the right platform, go beyond that even further in terms of bandwidth performance.
One of the funnest parts of XMP is working with our partners, our vendors out there, innovating. So we work with them from sharing the XMP specifications, talking about targets, working with them on every single new platform we roll out, certification programs that we have with them so they can self-certify modules. So all kinds of activities, including events, workshops, coming up with innovations, hearing what they like, what they would like to see us modify in the future to make it stronger. It's great to hear from them, the traction they're getting with customers. We're just seeing XMP volumes just explode. And you know what, that personal connection with the vendors, they share our vision of, exposing that last ounce of performance, hitting those world record frequencies, and then also those stable frequencies that everybody can achieve. And it's just a blast to work with those vendors. So
Corsair and Intel are obviously already collaborating on the next generation of products and also improving current gen products. For example, our power supply team works with the Intel power team to develop and improve specifications for future products. As well as on the memory side, we work with the XMP team to develop XMP and enable new technologies.
Intel and G.Skill has worked closely throughout the years, mainly to develop high-performance memory kit support for each new generation of Intel platforms. So before the release of every platform, we would actually work closely together to make sure that these high-performance memory kits that we have ready has support on these new platforms so that the end users and the customers, when they buy that new system, they will be able to enable these XMP memory kits, these high-performance overclocked memory kits, and achieve higher performance on these brand new systems.
We're really excited about DDR5 XMP. We're just seeing the growth happen. We've seen people vendors grab hold of those innovation opportunities and really utilize the additional profiles. You'll see more about our rewritable profiles and that just taking off. And then just the robust stability of that one-click overclocking experience. One-click overclocking is really, the advantage of XMP. It just removes that guesswork, makes it easy, hassle-free for the user.
With DDR5, we are very excited about the direction that we're going. We know now that the standard is DDR5 4800, ranging up to DDR5 5600. Our XMP-enabled memory kit goes up to DDR5 8000. And what we have in store for the next Intel platform, we understand that there is more room for higher memory frequency. And we're excited to see that happening on the next Intel Core platform.
The future of XMP is bright. It's growing every year. XMP is just taking off. It's used in all new ways. We have XMP UDIM for desktop. We have a new XMP RDIM, which is for our workstation Xeon line of overclocking modules. And then we still have our XMP SODIM for notebooks. So we have those three flavors, and we are continuing to expand. There's so much I'd love to share that we can't share today, but you're going to see XMP continue well into the future.